It is given that in the arrangement shown in figure 4.8, the sleeve M of mass 0.2 kilogram is fixed between two identical springs whose combined stiffness is equal to X, which is equal to 20 Newton per meter. So basically over here we are having a spring which is connected to a block of mass, let's say M, and the other part of the spring is attached to a fixed point, and this system is rotating with an angular velocity, let's say, that is represented by omega. So it is rotating with an angular velocity omega over here. Now if the stiffness of the spring is taken as k and this one is taken as k, and we know that as these two springs are connected in parallel combination, the value of k equivalent, the value of equivalent spring constant will be equal to 2k, which is given as nothing but 20 in the question. Now just consider that this object is displaced from its mean position by a distance, let's say, that is equal to x. So we can find out what are the forces acting on this object. There will be a restoring force which is exerted by the spring on left side, that we can take it as something but kx along this direction. Like that spring on right side will also exert a restoring force of kx, and there will be a centrifugal force that we can take it as mr omega square. Here the value of r is nothing but x, so mx omega square is acting away from it. So just for calculation purpose, take it as this angular frequency of omega dash, and the value of means angular velocity is taken as omega dash. So you can find out what about the value of net restoring force acting on this object. So over here the net restoring force acting on this object will be equal to nothing but 2kx minus mx omega square, omega dash square. Now for the calculation of time period, we can just equate that to the general equation minus of m omega square into x. Here this omega is angular frequency and omega dash is angular velocity. So we can find out the value of this omega, that is equal to 2k minus m omega square, omega dash square, divided by m will be the value of its omega, or you can write the value of omega will be equal to nothing but 2k divided by m minus omega square under root of this. So we can find out the value of time period over here. So just we can guess time period is equal to 2 pi divided by omega. So we can write over here time period is 2 pi divided by under root of this 2k is represented by x in the question, x divided by m minus omega square. Now if you are putting the values of x, m and omega square, then you will get the value of time period as around 0.7 seconds. Now in the second part of this question, they are asking find the period of small oscillations of the sleeve as well as what value of omega will there be no oscillation of the sleeve. If it is not oscillating, then we can take it as time period will be equal to infinity. So for getting the time period as infinity, the denominator should be equal to 0, and for making the denominator as 0, we can just consider that it will happen when the value of x by m is equal to nothing but of omega square. So the value of angular frequency becomes equal to root of x divided by m, and the value of x is given as nothing but 20, and the value of m is given as 0.2, so it is root of 100, or we can take it as 10 radians per second.